Hello students, I would like to show you some things that I found out on Desmos that are going to be helpful in terms of finding p-values for this next exam. So while I'm in Blackboard here, let me show you what I have inside of the video lessons. The last of the video lessons were uploaded in week 10 and 11. So there's no new content in week 12. Week 10 has hypothesis testing for the mean when sigma is known versus unknown. And here's homework from that. I wanted to do some of the homework problems, or a couple of them at least, so that you could see how you can use Desmos to get your p-value very quickly. So let me click on the hypothesis testing homework. And let me make it bigger. And I'll just pick one at random here. I'm going to choose number 6. There's more than one way to do these hypothesis testing problems, but we're presenting just one method, and that's the p-value method. All right, so I've got everything I need in this picture. The average cost, that's 117.91. That guy right there, that'll be mu. A random sample of 36 new homes. That's n. I don't know where I can put n, but I'll put it in there. There's n. The mean cost of the sample, that there is x with a bar, and the population standard deviation was 20. So this is where we know the population. I mean the standard deviation for the population. So that guy right there is sigma. Can it be concluded that the mean cost differs from 117.91? Use the 0.10 level of significance. So let me draw my two things, that H naught and HA. HA we're talking about differs from, so we're suggesting that the HA is mu does not equal 117.91. And then of course this is mu equals 117.91. This is the claim. And it's two-tailed. What that means is we're going to take this and divide it by 2. So that's the p-value. We're going to compare the p-value to the 0.05. Well, here we have our mean cost here. So check this out. I'm going to come into Desmos. Start the graphing calculator. Now I'm going to go down here to this keyboard, go into functions, and since we're dealing with the normal distribution here, I can grab the normal distribution. Okay, now what you do inside of the parentheses is you put the mean and the standard deviation. So if I come back to the problem, my mu was up here, 117.91, and the standard deviation was 20. So come back. So 117.91. Standard deviation is 20. Tell it that you want to find the cumulative probability. And then let's go back to the problem to find out. 122.57 is more than halfway. So let me come back. 122.57 and leave that as infinity, like so. You can just type in infinity. Up, I didn't, that is not, I'll try this again, INFINITY. There, it locks it in place. So right now I have 0.40. Now the only difference here is we have to divide by the standard deviation. So divide by, and here you can type in SQRT 20. Let me come back. 36 actually. Sorry, that was my bad. 36. Now you can also, if you go and center the graph at 117.91, so let me pop over here and I'll choose my smallest x to be like 110 and my largest one to be like 125. I'll see if I can capture the graph. It's in there. Now, the y-axis, it's going to go anywhere from about 0 to maybe 0.5. Let me try. 0. I'm going to tab my way to the next 0.5 and let's see if I can see it. There we are. There we are, right there. So let me move this up a little bit. I would like to move this graph up so I can have everything together on one screen. This number here is the p-value. You don't have to do the z where you change it to a z or anything like that or look up a table or anything. Everything is right here on one screen. So come back here. Make this a little bigger so it's easier to see. And here we have it. This is the p-value right here. And that's it here. Now remember, we were supposed to compare the p-value versus half of the alpha value. So the p-value is 0.08, I'll go to 4 decimal places, 0.0811, and alpha, or 1/2 alpha, was 0.05. So the p-value is greater than that, which means do not reject. H naught. Here's another one where we know the standard deviation of the population. We have a study found that the average stopping distance of a school bus traveling 50 miles per hour was 264 feet. A group of automotive engineers decided to test that. And for 20 selected randomly buses, the average stopping distance was 262.3 feet. And we know the standard deviation of the population. So let's get some of these things down here. This is potentially, no, I almost circled the wrong thing. This is our mu. We have found that 20 randomly select buses, so there's our n. And this here is x bar. And the standard deviation of the population was 3. So that's sigma. Alpha is 0.01. Test the claim that the average stopping distance of the company's buses is actually less than 264 feet. So let's put our H naught and our HA. So they have reason to believe that the mean stopping is less than 264. This is their claim. And this is also a left-tailed test. So the H naught would have to be mu is greater than or equal to 264. Now I'm going to go and put these things in. So when I go and do where'd it go? Let me come back over to Desmos. So now the mean that we're using here is 264. The standard deviation was listed as 3. Now, how many cars were there? 20. Now, we're going to go from negative infinity. Negative, you can type in a negative and then I-N-F-I-N-I-T-Y. I forgot my F, so it won't. What happens is when you get it correct, it locks into place once you type that. And it's going to go, let me get that other number, to the mean that was found, 262.3. Now, it gives you the answer whether you can see it or not, but I kind of like to see the answer. So the middle of this graph is 264, so I'm going to go around up to 264 and see what I can find. So I'm going to sort of center my x values around 264. Maybe we'll do 260 to 270. Let's see if I can see anything with that. Oh, good, I see it. Okay, and then let me go ahead and I don't need to do any more. There we've got our graph. Let me cut it out. So here's what we have. The p-value is this guy up here. And that's the area of this region in here. Let's compare them. So my p-value, that was 0.0056. And then alpha, let me see what alpha was in this problem. Alpha was 0.01. So we can see alpha is bigger here. So reject H naught. Here's a problem where we do not know the standard deviation of the population. Instead, what we've got to do is compute the mean of this sample and the standard deviation ourselves. So I'm going to throw these numbers into Desmos. And I think the easiest way, probably, let me pop into Desmos here and see if I can arrange it so that I can see the data while I'm typing it in. Yeah, that'll work. And I'll give myself a little more space here so I can see. I think the easiest way to put data in, if you have to do it by hand, is type the letter D equals and start a bracket. Now each piece of data you have to separate by a comma. When you're finished, finish off. I don't even think you have to finish the bracket, but it says there's 15 elements in my list. Let me just check that real quick. 2, 4, 6, 8, 10, 12, 15. So I got all. I don't think you have to finish the data though, or the bracket. It'll automatically do it. And then let me go ahead and resize this thing now that I've got our data in there. And I am going to get the mean of that. You can see that it puts it there. And the standard deviation of that set. So I'm going to get rid of the thing I had from the previous example. And now we're going to do the t-distribution. So let me come back to the stuff that we have in the question. We have the average 1 ounce chocolate chip cookie contains 110 calories. So that is our mu. A random sample of 15 different brands, so that's our N. And remember, since we're using the t-distribution, we have to know that the degrees of freedom is equal to n minus 1, that's 14. It'll be important when I do the numbers. Here's our alpha level, greater than 110 calories. So let's go ahead and write up our H naught and HA. So our HA is greater, so we're going to have mu is greater than 110 calories. That's our claim. And it's a right-tailed test. So here, mu is less than or equal to 116. Now, I have not been able to find as much of a way of decreasing this as before. What I mean is, it's got more steps in it than the one I just did. Here, let me draw a picture of this. We have 116. Now, let me go and find our mean that we got in the problem itself. And that's 137.3. So that's way over here. 3 with a bar over it. I can't put it in just like this. I don't have enough. Desmos doesn't have quite the capability that I need. Now, what it will do, though, is this. Once you go and get this, then you can put that in. So let's go ahead and get T. X bar was what again? That's right, the 137.3 minus 116 divided by, now this sigma of X bar, that's what we found over here. Come back here. I think what you should probably do here is we have to divide by the square root of n. I want to see if I can put in the square root. So SQRT 15. And indeed it does. 6.227. This comes up to 3.43. So what we do, come back to Desmos. This time it's going to be the t-distribution. Now you put the number of degrees of freedom in here, which is 14. And then you put the beginning and the end. So if I come back here to the picture, this starts at, well, technically this t-value is where our graph will start, but it will go to infinity. So I'll come back here. 3.43 will be my minimum, and the maximum will stay at infinity. And you can see that they have the number listed there. Let me go ahead and enter. And let me, since the middle here is 0, well, technically 0 for the standard t-distribution, let me center it at 0. So I'm going to go -4 to 4. Nice. It's way, way in here. I'm going to see if I can expand to that region so we can see it. You see it there? There it is, tiny little amount. Let me get you all these pictures. And once again, there's our p-value right here. And that corresponds to this area in here. You can see that the area is tiny, 0.002. And let's compare that to alpha. Alpha is 0.01. So alpha is indeed bigger. So we reject H naught. I would say that makes sense a lot here because the evidence you produced was so much bigger than 116 that H naught really seemed, or it would say that it's less than or equal to 116. That really seems fallacious. But then the mathematics that are important are all in the background you can't see. It's a combination of the sample size and some normality conditions that are imposed on these problems. Here's a problem dealing with proportions. This is the P that is proposed for the proportion, and we had a random sample of 500 enrolled students in a particular state revealed that 420 of them were undergraduates. So 420 is our X, 500 is our N. Remember, these proportions work under a normal distribution, so we don't have to use the t-distribution for this stuff. And remember, the p hat is equal to x over n. So that's 420 over 500. Now, what I'm going to do here, 86%, and it differs from, so we'll keep that in mind. The national percentage is 85.6%. And then here, of course, P would be equal to 85.6%. This is the claim. And it's two-tailed. So immediately, whenever you see two-tailed, first thing you're going to want to do is take this and divide it by 2. So now I am going to try something here that I didn't try. I want to plug it in as percentages. I want to see how little I can do to make this work. So we know that the center is going to be at 85.6%. Ours was 84%, so ours is to the left of it. Let me go ahead and throw this in. So I'm going to go ahead and delete all the rest of the things. And you can find it by typing the key, by going to the keyboard, or I don't know, I don't remember it, so I guess I'm going to go to the keyboard. I don't know how much of it needs you to type in before it recognizes the command. Oh, you type in normal dist, okay. And, oh, apparently it did not get rid of what I had there already. All right, so the normal distribution. Inside of here, you can specify the mean and the standard deviation. I am going to see if it will let me put 85.6%. No. All right. Well, let's see what the standard deviation we have in here was. Now, I think, see, the problem is I think you do have to go to Desmos because it won't take percentage. You saw that it wouldn't take percentages. So I'm going to go and do decimals. All right, so come back. And I'm going to put this in using decimals as well. I'll show you what I mean here. So we have the normal distribution, 85.6. That shouldn't be a big deal. The standard deviation, I'm going to try this, SQRT. And I'll put 0.856, and I should probably change that to 0.856. Then times, now in parentheses, I'm going to do 1 minus 0.856, and then finish that parenthesis. Divide, how big is n in this problem? 500. So there's our mean, there's our standard deviation, find cumulative. The first thing you got to do is give it the min and the max. So when we come up to ours, we had smaller, so we're going to go from negative infinity to 0.084. So negative infinity to 0.84. Now I'm going to put myself to right around the middle, since these are small numbers, so let me go. Let's see if I go from 0 to 1, if I capture anything. 0, oh, there's something, okay. Then 1, let me see if it stretches it out at all. Okay, here it is. I can shrink it down, I think. There we go. And I think it's really, so I'm going to actually go from 0.5 to 1. I'm going to decrease that. And how tall does this get? It's really up there. Well, we'll put it up. So let's go from 0.5 to 1. See if that makes it wider. The y-axis the y values can always start at 0, because these graphs never go under the y-axis. So we'll start it at 0. I don't know how tall to put it, maybe 10? Let's see what we have. Okay, so we're getting there. It's not quite 10. It looks like 27, holy cow. But it's very thin also. You can see the range. To get a good picture, I'm going to go ahead and set up everything. I think I'm going to go from 0.7 to 1. That seems about right. And then the y values, we're going to go from 0 to 30. Try to get it all on one picture. Here's our p-value. That's, of course, the same as in this area. And our p-value to 4 decimal places is 0.1541. And alpha, we had to divide it in 2, I think. Yes, 0.025. And we can see the p-value is larger than alpha, so do not reject. H naught. I hope this video proves useful to you in using all the power of Desmos at your fingertips and making these computations a little easier. Good luck.